Hare Krishna, guys. So, this one's gonna be a long video. And so, the thing which we have today is the week 5 assignment of the Joy of Computing using Python, right? So, we have here the quiz assignment, right? Uh, Here we go. Let's start. I have opened a Jupyter notebook where I will keep on just pasting the codes and trying to make you guys understand how it is working, and I'll also try to understand myself and figure out the answers. Let's go. Okay, def parity, return in mod 2. Okay, right. So suppose we have a function def parity, and what we have there is a number n. And what do? We do n percent 2. N can be anything. Suppose n is equal to 5. We call parity n, right? Okay, so let's see. The function has been called and we print. Okay, what a return in mod 2. Okay, return in mod 2. Right. Okay. So n is equal to 5, we get 1. Why do we get 1? Because n modulus 2 means what? When we modulus 5 with 2, 2 goes 2 times 4 and the remainder remains 1. So we are getting the output as 1. Right? So let's see here. Which of the following options correctly represent the possible outputs of the function defined above? Okay. So, right. 0 and 1 is true. No, 2 cannot be an output. Even and odd? No, never. 5 and 6? No. So 0 and 1 can be our only choice. Okay. Why when 0? When it's divisible by 2. Okay, let's go a bit fast. Let's see what we have here. Okay. We have a def uh, f of x. Okay. Right. Def function x. And what we are returning? We are returning uh, x star 3 plus 1. Right. We are multiplying x3 x into 3 plus 1, right? Now what do? We print what? F of 1 comma f of 2 comma f of 3, as I remember, comma f of 3, right? F of 1, 2 and 3. Yeah, f of 1, 2 and 3. Let's see what happens. 4, 7 and 10 is the answer. Yeah, 4, 7 and 10. Okay, def mystery function written 5. What type of mathematical function does mystery function represent? Okay, 1 to 1, 1 to many to 1, bijective. Okay, we have a mystery function, right? So let's write the function first. Def mystery function. Okay, what do we have here? Return 5. Return 5. Okay. So the thing is, we also have to figure out that what type of uh, mathematical function does it represent, right? Okay, so it's a many to one, right? Since multiple inputs map to the same output. No matter whatever input you give x as 10, 12, 13, 14, 1, 2, 3, 4, anything you give, 999, the output will be 5 only, right? Okay. A student defines the following functions to simulate a formula from maths class, right? Okay. Fine. Then they execute result is equal to weighted sum 1 comma z is equal to 4. What will be the this will be an error. Uh, okay, may not be. Okay, let's try it out, right? Let's remember the values first. Weighted sum x, y, and z. Return x plus y star z. Okay. Uh, def weighted sum. Weighted sum. Okay. What we have? X, y is equal to 2 and z is equal to 3. Right? That only we had equal to 2 and z is equal to 3 return x plus y. Return x plus y star z. Okay. Now what we have to do, then execute. Result is equal to weighted sum 1 comma z is equal to 4. Result is equal to weighted sum 1 comma z is equal to 4. Okay. Now we print the result, right? We print result. Print result. Okay. 9. Okay, as I said, uh, what happens here is basically if you hadn't mentioned the value of a, y, and z here in the function itself, then what would have happened? Then this could have arisen. Position of the argument following keyword are. Since here, if it is not getting one of the values, suppose here it is not getting y. So what happens? It will get y. You are updating the value of z. Yeah, z is updated, right? So what is happening here? Y is equal to 2, 4 2 are 8. X is we are passing 1. 1 plus 8 is 9, right? Okay. In the PyCalc system, two functions are defined. Double x return x star 2, add 3 returns x plus 3. A student composes them like add 3 double x, right? What will be the output of composed 4? Right. So 4 goes here. We don't need to do this, right? Now we will do the numpy once again. This one is easy. See, 4 goes into where? 4 goes into here, right? After 4 goes into here, what we do? Add 3 double x. First, what happens? Double x. So four goes here first. 4 star 2 8, right? So 8. We get what? We get double x. We get 8, right? So 8. Add 3 8. 8 goes here, right? 8 plus 3 11. So our output will be 11, right? The PyCalc team loaded a NumPy array and wrote the following code. Okay, they have made a 2D array. Print data.shape, data.reshape, print reshape dot shape. Okay, let's go. Let's do one thing. Let's just write it down. How many questions are there? Okay, there are way too many. 30 questions. We are in question number 6, right? Okay, no problem. Okay, import NumPy as NumPy data is equal to np.array 10, 20, 30, 40. Okay, import NumPy as np and data is equal to np.array. Okay, 10 comma 20 comma I comma 30 comma 40, right? 10 comma 20 comma 30 comma 40, right? Okay, print data dot shape. Nice. Print data dot shape. Okay, let's see what happens. Tuple object is not callable. Okay, what's happening here? NumPy np.array on np.array print data dot shape. Okay, see, dot shape in NumPy is an attribute, right? It's not a function. So this will be our um, answer to the question, that it raises an error because dot shape is not a function and cannot be called with a bracket, right? So this was easy one. Okay, let's see what we have here. Def manual sum LST. Okay, what do we have in our LST? Okay. Def manual sum, LST. Okay, result of 0, 1 and result of 1. Process list. Okay, let's send a list first, right? Let's find out what is result. Okay, result is equal to process list 1, 2, 3. Okay, the list goes here, right? Total is equal to 0. For I in list, for I in list matlab 1, 2, 3 in list as a I will keep on going. Total is equal to total plus I. Okay, what will be the total? 3 plus 2, 5 plus 1, 6. So we got the total as 6, right? So result is what? We got it as 6. Take it. Okay, now let's do one thing. We can just result हमारा 6 आया है. So the result we have got is 6. So result is equal to 6. I'm just confused with one thing. Print result of 1, 0. What will, 0, 1, I think it was. Right? 0, 1. Yep. Result of 0, 1. Yeah, what this will be? Yeah, this is a type error. Exactly. What will be printed? Okay, this is giving us a type error. Equal to total plus I. Process list. Okay, okay, I'm so sorry. I'm so sorry. I went to manual sum instead of going to process list. I misinterpreted it. I'm really sorry. Okay. So the thing here, what happens is basically, what happens this process list 1, 2, 3. This one goes here, right? In this. After that, what happens? Squares equal to third bracket. This is a new list, right? Squares. For item in L, for item in the list, squares dot append item square. Okay. So what happens? Squares dot append 1 square 1, 2 square 4, and 3 square is 9. Okay, we have 1, 4, and 9 in the list now. Return squares, comma manual sum squares. So what happens to the manual sum of squares? What is the square of 3 is 9 plus 4. 9 plus 4 becomes 13 and 1 14. So which option do we have 14 in? Yeah, this is the answer. And 0 1, which is the result of 0 1 means which position? The position which contains 4, right? Okay. Def identity. A return function called identity value equals just a value. Later, they write the following code. Print identity, print identity, print identity value. Okay. Okay, this one is a str object is not callable. True. If you see this, see. Suppose I make let these errors remain. These errors will help us to understand more like what is happening. A is equal to suppose my name Soham, right? So Soham. What happens if I try to call this as a function A? Type error. Str object is not callable. See, we are getting the same error here. Exactly, this will be our answer to the question. These are basically very easy. In exam also, in this exam, have you already, if you have already registered, you will get the same type of questions only. And these will be very easy to answer if you tend to find out the correct thing. See, the approach you have to understand. What I approached at the first. See, it's calling identity value. You have to understand that string is not a callable thing, right? So that is the only output we have here. Others are different, right? If you see now, then you can see, understand. See, identity is a function, it can be called. Print identity, what will happen? Function identity at. Okay. If you print a function, it shows. Like, see, here if I print weighted sum, print weighted sum, I'm not calling it, I'm just printing it. Weighted sum, right? Print weighted sum. See, function weighted sum at, right? So these are very basic concepts which they will be asking, and you can answer this very easily. The student is trying to understand the difference between variables and functions in Python. They write the following: def message, return this is a function, message is equal to this is a variable, print message. Okay. So see here what we are calling the function, right? We are calling the function message. Okay. Now the thing is we are calling the function message, but the thing here is okay. Okay. I have to try this one out. See, suppose we have here a def a. Okay. And within that, what we have? We have return, return, soham, soham. What happens? Okay. RETU, RN, return, soham. STR object is not callable. Soham, soham. Yep. See, what happens line by line checking is done while this is interpreted. So what happens here is see def message return this function. Okay, when here again we call print message, so first it goes back to this message because this was the last time it got it. So this will be an error. STR object is not callable. Student defines the following function to correct error logs during program execution. They run the following code. What will be the output? Okay, def log error message comma log is equal to null, right? Log dot append message return log. According to me, it should be empty. No, not empty. E1, E2, E3 is a good option. It is possible. Sending the message log dot append. Okay, we are appending it with log, and we are returning log. Log is at first time log is null. Uh, this will be the answer. Because see, when the first time log error goes, what happens? See, here the message goes, right? E1 is going, log is empty. Log dot append, E1 is entering. Next time what happens? We call E2. E2 goes, log, there is E1 in the log, right? Then what comes? E2. So E1, E2. And third time when we are sending E3, we are already saying that no, we want an empty list. So we are sending this. So this will be the answer to the question. This is very easy also. Okay, so this is the binary search implementation as you can see. Uh, and what do we have here? We have here the basic binary search. We have got ARR target, low is equal to 0, high is equal to len minus ARR. These are very simple things. If you know the binary search algorithm, you will definitely understand this. Okay, now we have these, right? So let's find out what are the answers, right? Okay. What is the time complexity of the worst case scenario for linear search? The worst case scenario for linear search is the whole array will be traversed. In the best case, what happens? You just traverse the array. In the first chance, you find out the output, right? Which condition must be met by binary search to function correctly? For binary search to function correctly, what should happen? The array must be sorted. Okay, binary search only happens on sorted arrays, right? It does not happen on any other array except sorted arrays. If you are doing binary search on an unsorted array, you have to first sort the array and then only you can do binary search, right? What will be the output of binary search 1, 3, 5, 7, 9, and 7? Okay, so what will be the output? Suppose you are finding out 7, right? So 7 is at index number what? 0, 1, 2, 3. So 3 will be your output. See, this is sorted. So that's why we can do binary search. This is the target, 7 is the target, and ARR is the list that we are passing. Okay? We don't have anything like other. In NumPy, we have arrays, but here what we do, we pass the values as listed only. This is the most easiest form. So this is the array, we have it. Okay, so index 3. So this will be 3. In binary search algorithm, what happens if ARR meet greater than target? Okay. And ARR meet greater than target, then what we do? We search the left half of the array. Okay. Since the array is sorted, if the middle element is larger than the target can only lie in the left half. You understand what I am telling? If the middle element is greater than the target element, right? We know the array is sorted. So target element is smaller, means target element is on the left hand side, right? Okay. So this is how this algorithm works. See, if ARR is mid equal, so target ही mid है, so the mid is returned. ठीक है. And so L if ARR mid is less than target, then what happens? Low is equal to mid plus high. Why? Because if ARR mid is less than target, then what we do? We have to, the middle element is smaller, right? So we have to find the right half of the array. Okay. So that is why we go to mid plus 1. We are going right. And else we go high is equal to mid minus 1. We go towards left, right? Okay. Now the thing is, in the following code, what value is returned? Okay. Let's see. We send an ARR. We send a 20. Acha, okay. One thing I'm telling you, in this type of questions, maximum time, what do students, if they don't have time, they mark all error, error, error. Error is the last option you should mark. Okay. There may be or may not be, but at maximum times there is no error. So here you can see ARR. Okay. See, this is very easy. What happens? ARR 10, 20, 30, 40. Whatever you do inside here, you will never find 25 because 25 is not in the array. So what will be returned? Minus 1 will be returned. When nothing is there, when all are failing, these conditions are failing, we are getting what? We are getting minus 1. So the answer will be minus 1. For a sorted list of 10 lakh elements, which search algorithm is generally faster for finding the values in term of average case performance, right? Uh, Binary search. Always binary search. Okay. Linear search is very slow, right? Linear search is very slow. Binary search is much faster than linear search. Okay. So usually using a binary implementation, what is the maximum comparison ARR of mid can be executed when searching a sorted list of 256 element? Maximum times the comparison. It should be 9. Why? Because uh, because see, it works on the formula of log to n, right? So we have n here as 256. So in binary search works as log to n. So if you do log 2 of 256, you will get it as 9 because 2 to the power 9 is 256. Okay. Sorry, I'm so sorry. 2 to the power 8 is 256. So in worst case, what happens? One extra step might be needed. So that case, the max is 9. Okay. Which statement is false? Linear search does not need sorted data. Binary search needs sorted data. Binary search always performs better than linear search. Linear search every element until it finds the match. Okay. Binary search always performs better than linear search is a very wrong statement. Suppose what happens? You have the element in the first round itself. So why would you go on doing a whole lot of searching and sorting and all this? You don't need it. So linear search is faster in that case when the element is present in the first position of the array itself, right? So there you don't need it. What will be the output of the following code? Okay, same thing. This will be also minus 1. Why? Because 4 goes here, ARR goes here. Is 4 in ARR? No, 4 is not in ARR. So all these have no more value. Straightforward, we go what? We see return minus 1. So it will be also minus 1. If the element you are searching for known to be at the end of 100 element list and you use linear search, how many comparisons will take? 100. Sure shot 100 comparisons will take place. Right? Okay. The Monty Hall problem is a famous probability puzzle based on a game show scenario. It presents the counterintuitive result that surprises many people when they first encounter it. Okay, the problem setup. The problem setup is what? You are Contestant on a game show. There are three doors. Behind one door is a car, the prize. Behind two doors are goats. Okay. I hope these goats are Messi and Ronaldo. The game proceeds as follows. You choose one of the three doors. The host Monty Hall, who knows what's behind the doors, open one of the two doors to reveal a goat. You are given a choice: stick with your original choice or switch to the remaining unopened door. You should switch or stay. Always switch. Always switch. Okay. Why? Because if you switch, your chance of winning is 2 by 3. This is a very common problem and it's a real life problem also. Always switch. Okay. Surprisingly, switching gives you a higher chance of winning the car. If you stick, your chance of winning is 1 by 3. If you switch, your chance of winning is 2 by 3. Okay. But it can also happen that the 1 out of 3, in the one case only you got the correct one, right? So this may also happen. Okay. Now the thing is, yeah, this is the code we are given. Okay, let's see. Okay, in Monty Hall, why does switching give a higher probability of winning car, even though there are only two doors left at the end? ठीक है. No. The initial choice had 1 by 3 chance of being correct, so switching the remaining gives 2 by 3. Okay, this is the. For the following, what does the hashtag mark line ensure? Right. Available doors is equal to I for I in range 3. If I not equal choice and doors of I equal go. ठीक है. It guarantees the host window. It helps consistent window often randomly opens a car door, changes the position of the car for available doors. Okay, let's check the code. Okay, here it is. Open the doors with a goat, not the chosen one. Okay, it helps the contestant win. ठीक है, क्यों? See, okay. So what we are given here, available doors I for I in range 3. If I not equal to choice and doors I equal goat, then what happens? Then random not choice available doors, right? Hosts open a door with a goat, not the chosen one. ठीक है. So it helps contestant win more often, right? Okay. What would happen if the list available doors included doors that might have a car behind them? Simulation would stop with an error. Advantage of switch would no longer hold. Okay. Okay, I got it. What happens if the list available doors include doors that might have a car behind them? Suppose this one available door is equal to this one have a car behind it. What happened? Okay, it will skip. Okay, nothing will get into that. The switch strategy would always win. The simulation would the probability advantage of switching would no longer hold. Makes it would make the list empty, right? Because why? Because the list only fills up when there is a goat. When there is no goat, the list won't fill up, right? Okay, what is the main purpose of random dot shuffle doors in the simulation? Random dot shuffle. Oh, okay. What it does is basically ensures fairness by randomly placing the, yeah, exactly, this one. Okay, to make the output deterministic. No. To ensure Monty open. No. The select. No. to ensure fairness by randomly placing. Okay, random dot shuffle. What it does, it shuffles it. Okay, which of the following modifications would incorrectly simulate the Monty Hall problem? Uh, which of the following would? Okay, let's check it. Let's check which of the following would do so. Uh, okay. Allowing Monty to open randomly an unchosen door, even if it hides the car. Okay. Which what does this snippet do? Remaining doors is equal to for I in range. Okay. So what it does is basically what the remaining doors, it finds out the remaining doors. Okay. If I for I in range 3, if I not equal choice and I not equal Monty opens. So which are these? Monty opens and choice. See, choice is the one which the contestant makes, and Monty opens is where the goat is placed. Okay. Available doors. Where randomly the host opens a door where the goat is there, right? So what happens? Remaining doors is equal to I for I in range. I should not be equal to choice and I should not be equal to Monty opens. Okay. So selects the door with the car, randomly opens the door, switches the player's choice to the remaining unopened doors, forces the player to lose. No. Randomly opens the door. I not equal choice and I not equals Monty open. No. Choice to the remaining unopened doors. Yep, this one. Right? Switches the player's choice to remaining unopened doors. Why is running the simulation with thousands of trials, 10,000 important? Okay. Okay. Let's see. Okay. So what we have here, why is running the simulation with thousands of trials important? To approximate the actual win probabilities using empirical evidence, right? You pick one of the three doors at random. What is the probability that your initial choice is wrong? My initial choice is wrong is like 2 by 3. Okay. Why? Okay. My initial choice. Okay. You pick one of the three doors at random. What is the probability that your initial choice is wrong? Of course, 1 by 3. Right. So there are three doors. I pick one of them. You pick door 1, Monty knowing the price location open door 3 which has a goat. What is the probability the car is behind door 2 if you initially pick the goat? 1, because it's sure it is there. What kind of probability concept does Monty Hall problem mainly help us understand? See, how probability changes when new information is revealed. Okay, this is the type of probability concept which Monty Hall helps us to understand, right? So these are the answers to our questions here. You can see them and you can do accordingly. Uh, I'll definitely recommend you to understand and then mark all the answers, because I know you'll skip to a part where you'll get all the answers. It's okay. I also once used to do my NPTEL exams that way, and when the exams like came in real, I used to do the assignments that way, and when the exams came for real, I used to like go and get 75%, 70%, 65%. You should always aim for higher, so that's why I'm making these videos with so long explanations. Thank you so much for watching, and stay safe, keep studying, and Haribol.